Hello, and welcome to Sorting Stacks and Queues. In this section, we will explore both the stack and the queue data structures. We'll learn how to implement them in Java and how to search and sort them. In this video, we will learn how stacks and queues work and how to implement them in Java. We will also discuss the principles of last in, first out, and first in, first out. We're going to start with stacks, and we're going to look at a fundamental concept. Imagine that this blue shape with the opening on the left is a parking queue. When the first vehicle goes in, it's the first in, and you can see that it cannot get out the way that it's pointing. It can only get out the way it came in. We can add 4 more cars, and they queue up after the first. And then when the last one is in, it's known as the last in. And then when we want to take one car out of our stack, or out of this line, the last one that was in is the first one that was out. You can see by this diagram that there's no other way to do it, because the only way to get out is the same way that the vehicles came in, and there are 5 vehicles blocking the blue one, which was the first to come in. So this is known as the last in, first out, or LIFO concept. Now let's use a little bit more industry jargon. So this is called a stack of cars, and we're going to push the blue car onto the stack. And currently that's the first in. It's also the last in. When we push the orange car into the stack, it becomes the last in. The blue, of course, is still the first in, and that will not change. On the bottom, we have 4 unused cars. So on our stack of cars, we have the first in and the last in. We can use the pop function to pop the last one that was in out. Again, the last in, first out. And that leaves us with 1 vehicle, which is now the first in and the last in. So looking at stacks beyond the graphical representation, stacks are a collection of things, right? In our example, we used cars, and it implements the last in, first out, or LIFO policy. It's just the way it is. The last item on the stack is the first one to come out. We push items onto the stack, and we pop items off of the stack. It's very easy to iterate through a stack, and you can use this to reverse order of a stack. Let's look at some code. I'm going to open the stack cars class. So here we're creating our stack. We're pushing 6 different cars. These might be valet key numbers. So when we push the first one, that comes the first in. Last one in is this one. Here we're going to output the value of the top element. We're using the .peek method, which I'll show you here in just a bit. And then we output the whole stack. We do that, we're going to say, well, the name of our stack is not empty. We're going to call the pop on the value, and then we're going to print that value, print a tab just to separate them, and then we're going to print a blank line. And then after we pop all of these to output the stack, we're going to attempt to output the value of the top element, or provide an empty indication. So this is a simple if statement. If the stack is empty, we're going to say that the stack is empty. If it's not empty, then we'll take a peek at the top of the stack. Okay, so here are the methods. This is the class with the class variables. Here's the constructor, and you can see we're not using is full, but I wrote it just out of habit. So we push an item onto the stack. We pop items off of the stack. We can peek at the top of the stack, and we can determine if the stack is empty or full by looking at the max size in the top. So let's go ahead and run this. It took 13 milliseconds. I'm going to scroll back up. So we can see the first in was the 3, followed by the 5, followed by the 17. The 2, then the 24, and then the 9. So we peek at the top of the stack. Last in will be at the top, and it shows us 9. And then when we output this stack, we use the pop, and it actually plops the item off of the stack before printing. And that's why when we try to look at the top one again, we receive the error, or not the error, but the indication that the stack is empty. That's really all there is to it. The key to knowing about stacks is that it is last in, first out. Let's talk about queues briefly, and then we'll go back into code. Queues are also a collection. They are similar to a stack. Major difference is they're first in, first out. It is also easy to iterate through a stack. And if you think about a queue as waiting in line, it actually comes from the British term for line, which is queue. This could be people waiting at a bank in line to get their turn to see a teller. So obviously the first person there should be the first person seen, second person in should be the second person seen, and so forth. So that's the difference. And we'll go ahead and look at some code to demonstrate this. So here we're creating the queue, and we're saying there's going to be 8. And then assuming these are student IDs, we insert a student into the queue one at a time. This is the first student that's in line, so we would hope that that's the first student that is seen. Let's say that they're at a library waiting to check out books, and then 7 others, and so this is the last student in. It should be the last student seen. There's no cutting in line. So for this output and processing, I prepended the comments and the output with a bracketed number, just so that our output will match what we have on the screen. It'll be easier to correlate it. So what we're going to do is we're going to output the number in the queue, and we're going to use the dot size. And we're assuming the first time that should tell us 8 because that's how many students we put in. We're going to output the value at the top. So we're going to peek at the first student. We're just peeking, we're not deleting. Then we're going to serve the first person in the line, and that should remove the student, because when you serve a student, you're taking them out of the queue. And then we're going to output the number in queue again. Then we'll output the entire stack, and then we'll output the size of the stack. So I'll show you the methods. Very similar to stacks again. So this is the class, the constructor. We're starting on line 68. You see our insert student. We could call it add, insert, whatever we want to, but we're adding a student to the queue, and they're going in the back of the queue to the rear. Chosen to on line 76 to call this function serve next student, and that will pop them off out of the queue, and everyone moves up. And then we have peek at first is empty, is full in size. And so here size just outputs the number of students, and number of students is one of our class variables. So scroll back up. We'll go ahead and run this. So at first there are 8 students in queue, and we just called the size function for that. That worked well. Output the top element, just the first student in queue. See here it's 885475, and it is indeed the first student that we put in the queue. Line 3, we're going to serve that first student. And then line 4, we're going to check the size again, and it should decrease from 8 to 7 since we removed 1 student, and it did work that way. Number 5, we output what's left of the stack. So here it is, this line right here. These are the 7 students that are left. And just like with the stacks, when we pop these out of the queue, they're being removed from the queue. So that's why when we check the size again here for number 6, there are 0 students in the queue.